Okay, once again, welcome. So, in the previous video, we had seen that tension is not equal in connected bodies. So, wherein what I did was I just took up an example of, I just took an example of two connected bodies and I found out what is the tension here, T1 and T2. They were not seen to be equal. So, same thing we applied here also. So, in case of a pulley also, the tensions were not seen to be equal if I have many bodies being connected. That's what we had seen. Now, let us look at one more. Tension is not equal to a different positions in a pendulum. Wow. So here what's happening is you have a pendulum of mass m connected here. It's connected to a string. Now as the pendulum swings, okay, you observe the tension is not going to be a constant. Here it will be something, and when it comes here, it will be something else. And here when it comes here, it's something else. Have you realized this? No. Okay, let us see that. Okay, and then we'll go for something else, some other problem on and pendulums to understand what happens there. Now towards it, as you see here, this tension here is balanced by this mg cos theta. Mg is the vertically downward force and mg cos theta is a component of mg along this direction. So tension is equal to mg cos theta here. So this itself clearly explains that at any position, see I put something like static conditions here. At every positions that I put here, is a function of theta over here. If theta is equal to 30 degrees, I get some value. If theta equal to 5 degrees, I get some value. Theta equal to 0 degrees, that means when the bob is at this point, tension will be maximum, which is equal to mg. This definitely tension is not going to be a constant. Okay. Now let us look at this example. In this example, this is a normal pendulum, okay, which oscillates about this axis, okay, and then this is what you see here. Now this is in case of a conical pendulum. Conical pendulum. What is a conical pendulum? A conical pendulum is one wherein the bob here, the pendulum's bob over here, does not oscillate like this. It never comes to the center, but it always describes a circle. See, it's describing a circle like this. It goes like this, describes a circle like this. This is what you call it as a conical pendulum. In that case, this is my tension. This is my tension. This is my mg. And if you ask me what is the tension at this point, let me remove my photo from here. Yes. Now, if you ask me what is the tension at this point, since mg is like this is my angle theta. So I can say this is mg cos theta. If suppose if the pendulum is at this point, okay, it's outwards. Now what happens is this becomes my angle theta. It's here. Okay. Let us say it's here. Okay. And this becomes an angle theta. And as a result of it, once again, this is my tension and this is my mg cos theta. Now, suppose if I consider one more point, let's say at this point. Now what will happen? mg is acting here. mg cos theta is acting here. So once again, this is my angle theta. If I consider one more point here, in reverse, right? So here. Now here also you see, this would be my angle theta. And once again, mg is acting like this. This is my tension. And this is your mg cos theta. Thus at every point you observe that the tension is always remaining a constant. Pendulum, okay, if I just learn pendulum, tension is not equal. Okay, this applies only for one of them. So the misconception here is that don't go only by the single term known as pendulum. Because in case of a normal pendulum, a simple pendulum, definitely tension is not the same at every position. But in case of a conical pendulum, the tension is equal at every position of its motion. I hope you understood this. Okay, so with this, I have not done any mathematics here. I just resolve the forces. That's it. Okay, don't think, what is this? He has not done anything. Okay, I have not done anything here. I'm just resolving the concepts when applied at two different scenarios, as I already told you. Okay, there's no problem over here. There's no numerical over here. No IIT JEE here. It's only about understanding a concept from different context. That's what we are doing. Okay, so with this, let me stop here. And in the next video, we'll see some more on tensions acting on a pendulum. Thank you, friends, for watching. And if you like this video very much, definitely like, share, and subscribe to my channel. for further updates so that it will be helpful for me also. It proves like an encouragement for me. Thank you.